So we're talking about triangle centers. And as we've talked before, there are 4 different triangle centers. What does that mean? Well, it means that when I'm talking about an equilateral triangle, it's really obvious what the center is. And it's the same distance from all 3 corners, and it's the same distance from all 3 sides. It's the same. But once I look at other triangles, what I see is that the point that is exactly the same distance from all 3 sides, and thus might be described as the center, is actually different from the point that's the same distance from all 3 angles. They're different centers. And there's 4 different centers. Those 4 centers are the circumcenter, the incenter, the centroid, and the orthocenter. And I like to consider that each of these has an if-then element to it. The if is how it starts. Well, the circumcenter is created by what kinds of segments? Perpendicular bisectors. And what is that? Well, up above here or down below, let's do it down below. I want to draw in exactly what a perpendicular bisector looks like. And let's make it a more obviously not regular triangle. Perpendicular bisector means it's perpendicular to this base, but not just anywhere. Where is it coming out of? Vertex. No, not coming out of the vertex. Where on this side? In the middle, because it's a bisector. So I have to find the middle of this side. And then from there, I go straight up, perpendicular. This is a perpendicular bisector. Now, will the perpendicular bisector always go through the vertex? No, it totally missed it here, didn't it? Doesn't have to do with the vertex. Are there times when we do an isosceles triangle and it happens to go through the vertex? Yeah, but it's not a necessary feature. So when we talk about the features of the perpendicular bisector, it does not have to go through the vertex. So leave that unchecked. It does have to go through the midpoint of the side. So that gets checked. It does have to be perpendicular. So that gets checked. But it's not a bisector of the vertex angle. How could it be? It doesn't even necessarily hit it. So how could it split it exactly in half? Any questions on what a perpendicular bisector is? Okay. Now, if I construct a perpendicular bisector or make one, how tall does it have to be? Does it need to be up here really? No, all I really need is starting from this midpoint, go up a little ways, far enough so that if I were to do it from the other sides, I would find where they meet. And what makes these centers interesting is that if I make these special segments from all 3 sides, they'll always meet in the same point, one single point. That point for the perpendicular bisectors is called the circumcenter. Now, each of these centers, like the circumcenter, has a superpower. It's unique and special in a certain way. What's unique and special about the circumcenter is that it becomes the exact center, the same distance away from all 3 vertices. Vertex is a corner or an angle, and these distances are all the same. The other thing that represents is that this circumcenter is the center of a circle that could be drawn around the outside of this triangle, such that this radius and this radius and this radius are all the same. I strongly urge you to draw this picture on your page as well. So what are we going to say about the important facts? What is the superpower? Well, the circumcenter is equidistant from each what of the triangle? Vertex. It's not the same distance from the sides. You can see it's further from this side than it is from this side. But it is the same distance from the corners, the vertices. So what would be a real-life example of the use of a circumcenter? Well, let's say that you draw some crazy flower bed. This is all your grass in your flower bed. And you've got a special flower here that you really love, and another special flower here, and another special flower here. And you want to put in a sprinkler head that exactly reaches all three of those flowers. What you'd need to find is the point so that the water goes right to that one, and right to that one, and right to that one. That would be the circumcenter, wouldn't it? But in contrast, let's say that you've got a same yard like that. This is still all grass. But now this is sidewalk running along the outside. And it's super hot in the summer. And what you're trying to do is find a way that your dog can be on a leash and be kept into the grass to never go on the super hot sidewalk. If you used the circumcenter as the center, your dog could walk outside here and get on the really hot pavement, right? So you wouldn't want to set up the leash to here. But if you use the incenter, which is the point that is the same distance to each side, such that I can actually snugly fit a circle on the inside of the triangle, my dog would be able to go anywhere inside of here, always having nice, cool grass on his feet, never going in this really hot pavement. Any questions on the distinction between circumcenter and incenter? Okay, so the incenter is formed by what? Question, Gus? Angle bisectors, good. And if I were to draw an angle bisector, let's come down here and do this in the bottom again. When I draw an angle bisector, where do I start? Let's say I want to draw one here-ish. Do I start down on this side, or do I start from the angle? You got to start from the angle, because I'm going to look at this and say, okay, this is 64 degrees. So I have to find the ray coming out of here that is exactly 32 degrees on this side and exactly 32 degrees on this side. It bisects this angle. So when I draw that angle bisector, will it definitely go through the vertex? Yeah, that's where I started. Will it definitely hit the exact midpoint of the other side? No, we don't know that. Will it definitely be perpendicular to the other side? Nope. But will it definitely bisect that vertex angle? Yeah. So given that I draw all three of those angle bisectors, one from there, one from there, and then one from there, they will all meet. And when they meet, this is the incenter. And the incenter has a unique feature that it's exactly the right distance to the side. Whatever this length is going to be exactly the same as this length. And remember that when I measure from a point to a side, what I'm looking for is that shortest distance, the perpendicular distance. So these three red segments would all end up being the same. Since they're all the same from a center point, if I set my compass to that length, I would be able to draw a circle that just barely fits on the inside of this triangle. That is the special feature. The incenter is equidistant from each what of the triangle? Side. Take a moment to get these notes copied down. Okay, any questions on angle bisectors and the incenter that it creates? Okay, third one, the centroid. The centroid begins by taking a triangle and saying, I want to slice this triangle in half. And so the way I'm going to do that is I'm going to pick the midpoint of the side and then draw that over to the other vertex. And then I do it to the other sides. Midpoint of the side over to the other vertex. And so again, what I'm using is here the medians, which include which features? Vertex and midpoint. They're not perpendicular. They're not angle bisectors, unless, of course, it happens to be that special equilateral triangle where all these points fall on the same point and then they've all got all the features. That's not what's really going on. Bless you. What's the center's superpower? It actually has two. One is, ever go to like Pier 39 and you see people like spinning stuff or juggling knives or whatever it is, they're there to entertain you, right? And I've seen people spin some pretty crazy things. How do you spin an object that is not balanced like a ball? You got to find the center of gravity, right? Put your finger there and then it spins naturally. Well, in a triangle, if you're trying to find what that point is, it's this one, it's the centroid. This point has exactly half of the weight over here and over here, and half of the weight up here and half of the weight down here, and half the weight here and half the weight here. So this becomes the center of gravity, or the balancing point. And when you guys get to physics, you'll discover it's not really the center of gravity, it's called the center of mass, but this is more intelligible for this point. And the second feature is that this center, centroid, perfectly splits each of these medians into a 1-to-2 ratio. So if this shorter part is 5, how long is the longer part of that same median? 10. And if I know that this longer part is, let's say, 36, how long is the shorter part? Half of that, or 18. And if I know that this whole median is 30 units, then this one is 10 of it, 1/3, and this one is 20 of it, to make a total of 30. Any questions on the centroid? Fourth and final point is the orthocenter. The orthocenter is produced by creating altitudes. And let's say that this is a mountain and you're standing up here. I can't believe I climbed that altitude. What does it mean? Does it mean you're going to measure how far you walked up this side? Does it mean you're going to measure how far the rock face is over here that you're thinking about belaying down? Straight down. It's perpendicular to the base, but definitely goes through this vertex, because that's the point I'm measuring. So up here, does it go through the vertex? Has to. Does it go through the midpoint? Does it go through perpendicular? Yes. Is it an angle bisector? No. And the center's superpower? Sorry, dude. None. This particular point shows up in some interesting things if you're a really detailed and probably reclusive math person. Like there's something called a 9-point circle, which is 9 specific points that all fall in a circle in a triangle. It's like the 4 centers plus some other interesting points, and they all happen to coincide in a perfect circle. It's kind of cool. It's really weird though. And not for high school geometry. It's just not what we need. Altitudes. Okay. So now, yeah, question. Well, what are you trying to do? You're trying to demonstrate what it is that's happening? Yeah, it's going to be the intersection of all 3. If you drew 2 of them, that would be enough to find the point of intersection if you drew them well. But really, the point of these pictures is to help you see what the parts are. So your test today is going to have 2 different tests on this. The first test is, what do you call these parts? And so, for example, I might give you a picture like this and say, what segment is this? And you'd say, okay, well, I see it's perpendicular. The only ones that are perpendicular are the perpendicular bisector and the altitude. So the question is, does it go through the vertex or not? It doesn't. Therefore, this is what kind of segment? What kind of segment, not what center? Perpendicular bisector. You're right. If I were to take it one more step and draw 2 or 3 perpendicular bisectors, now if I asked you, what point is this star? What would you say? You'd say, these are perpendicular bisectors. And when I look at perpendicular bisectors, they make the circumcenter. They're on column 1. So you'd call this a circumcenter. That's test number 1. It's going to ask you what the segments are, and then it's going to ask you what the centers are. Test 2 is going to be asking about the conclusion part. Like if you see something like this, what is that? These are showing that the distance from this point to all 3 vertices are the same length. Circumcenter. This is the result, the superpower being shown of the circumcenter. What if I were to show you something like this? Incenter. And I could also have done the incenter by just showing you that these lengths are the same. Okay, you guys ready? So here's what I'm going to ask. 1, we're going to put our phones in for the calculators. 2, you're going to send 1 representative from your row to get 4 Chromebooks and distribute those. 3, you're going to leave this note sheet on your desk. This note sheet is available to you during the test. No other notes are. You will only be able to take each of the tests 10 times. No, Junior Chromebook. I will only keep your top score.